So in this experiment, I'm performing feature selection and feature extraction techniques to improve the model performance by selecting features and reducing the dimensionality. First, as usual, we are importing the data, that is, we read the data from the side. Next, we have to drop some columns. Some The columns can be dropped using drop command. Now we have to identify and drop the column with outliers. So I calculate Q1, Q3, and using IQR method, check the values which contain outliers and store those column names and temporarily drop from the dataset. For next, we have to drop the column with variance, which is less than 10, and we have to display the size. For this, I calculate the variance using VAR and identify the columns which is less than 10. Then these columns are remain temporarily. So now we have to identify low correlation with target. So the features which has very low correlation, we have to calculate it. So I calculate the correlation with price and select the column with correlation less than 0.2. Now we have to drop the columns which is less than 0.2 correlation and display the size. Here, removing the weakly related features, we can improve the model efficiency. So here, I drop the columns from the temporary data frame and check the new shape. Now, we identify the highly correlated feature pairs. So I compute the correlation matrix, take the upper triangle, and identify the feature pair with correlation which is greater than 0.8. Now we have to drop one feature that is from the highly correlated feature pair based with the target feature price. For each pair, I compare their correlation with price and drop the feature with lower correlation. That's how the values is calculated there. And now we have to separate the input feature and target feature from the data frame. So I assign price as Y and select available input column as X. And then I display the shapes for the each input, each feature. Now we perform univariate feature selection using select K best from scikit-learn library. So univariate feature is like we select the best feature based on the statistical test. Chi-square measures dependence between features and targets. So here I ensure if all the values are non-negative, then I use the method select k best with chi-square to select the top feature and print their names. So here now for mutual information stored, uh, we measure how much information a feature provides about the target. So I compute scores using mutual info regression and identify the feature with highest importance. And the values are calculated here. Now, uh, Now, feature extraction using PCA. PCA is principal component analysis. This is the concept where it reduces the dimensionality by transforming features into correlated components by preserving maximum variance. So first here, I remove the zero variance column. Then I standardize the data. Next, I compute the data. After that, I perform eigenvalues, and then I select the top two components and project data onto them. Now, to perform feature extraction using LDA. LDA is linear discriminant analysis, which reduces the dimensionality while maximizing class separation. So, in this code, I apply LDA using sklearn and transform the data set into lower dimension based on class labels. Here, we read an image and extract the pixel mean feature and display it. First, we imported the picture and by using feature, we plot every points and we get the original shape and mean feature shape of the picture. And finally, we print the columns which is active. Branches.